This video introduces a TinyML-related project that won first place in a WIZnet internal evaluation. On resource-constrained IoT devices, it's not feasible to always enable voice recognition. Voice recognition on smartphones, such as the iPhone, requires you to say certain words first, such as "Hey, wa Siri," so you need to use voice recognition to manage resources efficiently. The pipeline of a project. The main components are the PC, the Arduino, and the reasoning process. On a PC, you build and spectrogram your voice into a dataset and train it through a CNN neural network. We then use TensorFlow Lite to lighten the model to make it inference-ready on the device. First, the Arduino makes the connections to allow you to input the data, your voice, and then it turns the audio data into a spectrogram. Import the TensorFlow Lite weight file that you previously trained on your PC and create a backbone model. Classify the spectrogram data with CNN image classification to label and display LED lights. It is difficult to extract characteristic values from the sound source itself, and since the number of characteristic values increases exponentially, it is impossible to extract characteristics from sensor values alone. Perform a Fourier transform on the sound source to change the waveform on the time axis to a waveform on the frequency axis. Try Fourier transform by dividing the time of the sound source into short segments. The accumulated form of the Fourier transformed graph by rotating it counterclockwise is called STFT. The size of the frequency range is expressed as a value between 0 and 255. In this code, we attempted Fourier transform by converting to 257x4 tensor. The model is composed of layers of neural networks. It is a typical CNN-like layered model for classification. Second, due to the limitations of TinyML's computing resources, we lowered the model complexity to make it reasonably tractable. It shows an unstable learning situation because the dataset itself is not large enough. In the case of the losses, the sudden spikes make it less accurate, but overall it appears to be learning. Considering that there are 3 types of classification and insufficient data, I am satisfied with the higher accuracy than expected. Save the trained model and quantize it to int8 with TensorFlow Lite. We learned how to use modeling and TensorFlow Lite on a PC for speech recognition in our project. Next time, we will go into more detail about how the project is carried out on the Arduino.